Adjacent literal strings are concatenated by the Python compiler into a single string, which, although at first it seems rather pointless, can be useful for nicely formatting code, as we'll see later. If you want a literal string containing new lines, you have two options: use multi-line strings or use escape sequences. First, multi-line strings. Multi-line strings are delimited by 3 quote characters rather than 1. Here's an example using 3 double quotes. Notice how, when the string is echoed back to us, the new lines are represented by the /n escape sequence. We can also use 3 single quotes. As an alternative to using multi-line quoting, we can just embed the control characters ourselves. Or, to get a better sense of what we're representing, we can use print to see the string. If you're working on Windows, you might be thinking that new lines should be represented by the carriage return new line couplet /r/n. There's no need to do that with Python, since Python 3 has a feature called Universal New Line Support, which translates from the simple /n to the native new line sequence for your platform on input and output. You can read more about Universal New Line Support in PEP 278. We can use the escape sequences for other purposes too, such as incorporating tabs with /t, or allowing us to use quote characters within strings by using a slash followed by the quote sign that you want. See how Python is smarter than we are using the most convenient quote delimiters. Although Python will also resort to escape sequences when we use both types of quotes in a string. Because the backslash has special meaning, to place a backslash in a string, we escape the backslash with itself. To reassure ourselves that there really is only one backslash in that string, we can print it. You can read more about escape sequences in the Python documentation at python.org. Sometimes, particularly when dealing with strings such as Windows file system paths or regular expression patterns which use backslashes extensively, the requirement to double up on backslashes can be ugly and error-prone. Python comes to the rescue with its raw strings. Raw strings don't support any escape sequences and are very much what you see is what you get. To create a raw string, prefix the opening quote with a lowercase r. We can use the string constructor to create string representations of other types, such as integers or floats. Strings in Python are what are called sequence types, which means they support certain common operations for querying sequences. For example, we can access individual characters using square brackets with an integer zero-based index. Note that in contrast to many other programming languages, there is no separate character type distinct from the string type. The indexing operation we just used returns a full-blown string that contains a single character element, something we can test using Python's built-in type function. There will be more on types and classes later in the course. String objects also support a wide variety of operations implemented as methods. We can list those methods by using help on the string type. Ignore all the hieroglyphics with underscores for now, and page down until you see the documentation for the capitalize method. Press Q to quit the help browser, and we'll try to use that method. First, let's make a string that deserves capitalization, the proper noun of a capital city no less. To call methods on objects in Python, we use the dot after the object name and before the method name. Methods are functions, so we must use the parentheses to indicate that the method should be called. Remember that strings are immutable, so the capitalize method didn't modify C in place, it returned a new string. We can verify this by displaying C, which remains unchanged. You might like to spend a little time familiarizing yourself with the various useful methods provided by the string. Finally, because strings are fully Unicode capable, you can use them with international characters easily, even in literals, because the default source code encoding for Python 3 is UTF-8. For example, if you have access to Norwegian characters, you can simply enter this. Alternatively, you can use the hexadecimal representations of Unicode code points as an escape sequence prefixed by /u, which I'm sure you'll agree is somewhat more unwieldy. Similarly, you can use the /x escape sequence followed by a 2-character hexadecimal string, or an escaped octal string to include Unicode characters in a string literal. There are no such Unicode capabilities in the otherwise similar bytes type, which we'll look at next.